Hey guys, what's going on? Mr. D here with the final video for 6.4 and actually final video for all of Unit 6. Today we're going to be talking about compound interest. Very similar to what we did last time when we were looking at exponential growth and decay models. But now we're actually adding a little bit more to our equations that we were using yesterday. So they look very similar to what we used yesterday, but we are adding a few more elements, a few more variables. So let's go ahead and start talking about a few things that will get us jump started into our topic today. All right, first off, let's go ahead and see if we have a little bit of background information. If you guys remember a few of these things or what these keywords mean. All right, guys, so when we talk monthly, okay, what are we talking about? Okay, well, when we're talking about monthly, we're talking about every month, okay? And so every month. So when you think of every month, how many months are there in a year? Well, there's 12 months in a year. Okay? Nothing crazy. I'm not asking you guys any trick questions here. I just want to make sure you guys know what each of these words mean. So basically, you hear the word monthly, you're looking at 12 months. Okay? So that's the value you're going to use whenever you have those types of problems. All right. Next thing, quarterly. What does quarterly mean? All right. Hopefully you guys remember that quarterly means 4 times a year. Okay. If you think of, oh, let's say, well, actually, how about this? When you think of how many quarters of in school you have, okay, first semester has first quarter and second quarter, and then second semester has third quarter and fourth quarter. Okay, so you're looking at quarterly. Okay, another way to think of it is a quarter. Okay, a quarter is 25 cents. All right, so exactly 1/4 of a dollar. So in order to complete a full dollar, you need 4 quarters. Okay, so there are 4 quarters in a year. So once again, if you hear this word quarterly, we're talking about 4. All right. How about semi-annually? A little bit more challenging. Semi-annually. Well, how about this? How about when you're talking about like a semicircle? Okay. You're talking about a half of a circle, right? So how many would you need to have a full circle? Well, you will need 2. Okay. So when you talk about semi-annually, you're talking about 2 times a year. Okay. For example, I pay my car insurance semi-annually. I pay it once in August and then once again in, I believe it's February. So I pay it twice a year. Okay, so that is what semi-annually means. So once again, if you see this word semi-annually, we mean, that's probably not a good choice of color here. If you see semi-annually, we mean 2 times a year. All right, and finally weekly. Let's go ahead and use this color here. Go ahead and use actually let's use purple. Weekly means what? Well, it means every week. Okay, and how many weeks are there in a year? If you don't know this, there are 52. Okay, there are 52 weeks in a year. All right, so if you hear the word weekly, we're talking about 52. Now, keep those 4 numbers, those 4 values, and those 4 keywords in mind, because when we talk about compound interest, we're going to be using those. Okay? Now, compound interest formula. Very similar to what we used yesterday, for example, with exponential growth. Remember? That was A of t equals p 1 plus r raised to the t. Right? Those 2 formulas, this one and this new one, was very similar. And the reason why is because a lot of those variables mean the same thing. So once again, our A of t, or in this case our A, is actually our ending amount, just like it was yesterday, or in the previous lesson, I should say. Ending amount, or ending value, balance, whatever. Right? Our R is still a rate, or a percent, which we have to turn into a decimal. Don't forget about that. It has to be in decimal form, which means basically move the decimal to the left twice, or take whatever percentage it is and divide it by 100. All right, our P, once again, is our initial value, our initial balance, initial amount, whatever you want to call it, but it's whatever initially we are given or we know. Okay, and now this is the new thing. So this right here is the new portion. This is the reason why we went over every single one of these things up top here. All right. Our n means the number. Let me get my pen here. It means the number of times each year. So let's recap. If I say something is compounded monthly, we're talking about 12 months. So your n would be 12. If you talk about something is compounded semi-annually, then the number of times each year would be 2, meaning our n would be 2. Okay, so let's keep those two things in mind, guys, and also let's try to remember to use this formula for compound interest. Okay, this is only for compound interest. All right, and one easy way that a very special teacher showed me how to do, or rather not do, but remember this, is this way. See that R there? If you look at the R, you have a runny nose needs tissue. So RNNT, that's one easy way to remember it. So RNNT. Shout out to Miss Lupo for showing me that. I'm sure she probably heard it from someone else, but if she didn't, that's even bigger reason why she's so awesome. But anyways, quick shout out to her. So that is an easy way to remember this, guys. Let me go ahead and erase this again so I can show you again. RN and T looks very different than this one, so we have to remember runny nose needs tissue. Okay? I actually need tissue right now. But anyways, sorry guys, I'm a little bit sick. That's why I was sneezing earlier. So, example number 1. Let's go ahead and start finding out a few of these variables from our formula. And let's keep an eye out for those keywords that we may see throughout the problem. So it says, when Ricky was born, his grandparents deposited $3,000. Okay, I'm just going to go ahead and highlight a few things that I see right off the bat. All right, they deposited $3,000 into a college savings account, paying 4% interest, compounded quarterly. Okay, all right. It says, assuming that there are no deposits or withdrawals from the account, what is the balance after 10 years? Okay, so we are using our compound interest equation. So that's A of t equals P1 plus, remember guys, if you can't remember it, come right back up here, but remember our little, our little trick here. It's runny nose needs tissue. Okay, write that off to the side, guys, if you don't remember it. Runny nose needs tissue. Okay. R, N, N, T. R, N, N, T. All right? Okay, enough of that. Let's go ahead and start finding out some of our values here. So, our A of T, or A in this case, okay? Actually, I'm not going to call it A of T, just to make sure this doesn't get confused. I'm just going to call it A, just like we have it up top on our formula. So I'm going to just call this A. Okay, so we have an A, we have a P, we have a R, we have an N, and we have a T. Almost forgot the T. Okay, so we have 5 things we need to know, or actually at least 4 of the 5 things we need to know in order to find that 5th one. Okay, let's go ahead and read through the problem again and identify what key things we are given within the problem. When Ricky was born, his grandparents deposited $3,000. That is an initial amount that was deposited into his account. So an initial amount is my P. So $3,000 is our P value. Now it says that money was deposited into a college savings account at 4% interest. Okay, 4% as a decimal is 0.04. Again, if it doesn't make sense, type this into your calculator. 4 divided by 100, you should get 0.04. Okay, or just move the decimal to the left twice. But you guys are probably pretty good at that now. Okay, now next thing it says that account was paying 4% interest compounded quarterly. We had just gone over what that means. Quarterly, think of a quarter. Okay, we need 4 quarters for an entire dollar. So our N is going to be 4. Finally, down at the bottom it says, assuming that there are no deposits or withdrawals from this account, what will the balance be after 10 years? So that is the final piece of the puzzle. Now I can start substituting things in. So this is going to be A equals my principal, which is 3,000. Then we have 1 plus R, which is 0.04, 4, and then we have, let's see, we have a 4 and a 10. All right, let's go ahead and type that into the calculator and figure out what we have to do next. All right, let's see what we get. Well, first off, guys, this is actually an easy way or easy trick to make sure you calculate this correct. Calculate this first. Okay, what is 4 times t, guys? I'm sorry, 4 times 10. Okay, 4 times 10 is 40. So what you should actually be typing into your calculator is this: 3,000, 1 plus 0.04 over 4, and then raised to the 40. Okay, and actually, you're going to want to put that in parentheses as well. Okay, these are a little bit tricky, guys, because we have a lot of numbers here. You have to make sure you use the right amount of parentheses and you do the right amount of calculations here. This can get a little difficult if you don't do it correctly. All right, I'm going to go ahead and type that into my calculator. I'm going to see if I can get my answer, and then that way you can check to see if you are typing it into your calculator correctly. So this is 3,000 times parentheses 1 plus, and I'm going to put another parentheses, 0.04 divided by 4, close one parenthesis, close the second parenthesis, and then raise that to the 40. And you should have gotten $4,466.59. Remember, we're talking about money here, and so you have to round it to the nearest cent. So basically to the nearest hundred. And this is what you should have got. Whoops, I did not mean to do that. This is what you should have gotten as a final answer. So again, guys, This right here is what you want to type into your calculator. All right. Put that second set of parentheses in that division, okay, in that fraction, okay, and make sure that n times t, remember this is n times t, so 4 times 10 is actually 40. So after you type all that into your calculator, you should be able to find your answer, which is $4,466.59. Now, we have a part B to this problem. It says, what will the balance be after 15 years? So the only thing that changes now is our t. So once again, let's go ahead and write our equation. So this is 3,000, 1 plus 0.04, and then it's still compounded quarterly, right? And then we have 4 times, and instead of a 10 now, it's a 15. So once again, before you type this all completely into your calculator, what you're going to want to do is multiply this 4 times 15. So that should give you a 60 out here. And then around this, make sure to put a parenthesis. So this is going to be 0.04 over 4. That is what I want you to type in your calculator. Let's see. Let's go ahead and type that in. And if you type that in correctly, actually you can do second entry. So second enter, and your whole equation should pop back up. You just have to edit the 40 instead of a 40, you're going to put a 60. You should have, for a final answer, $5,450.09. So after 15 years, Ricky should have $5,450 in his bank account. Okay? All right. Let's take a look at number 2. Once again, guys, keep in mind everything you had in that first page. Don't forget it. Or rather, the front side of this page. Okay? So let's go ahead and read through this, and then I'm going to have you try number 3 on your own. So it says, when Ricky's sister Amanda was born, his grandparents also deposited $3,000 into a college savings account. So they also deposited $3,000 into a savings account of 5% interest, compounded semi-annually. All right. Now it says, assuming that there are no deposits or withdrawals from the account, what will the balance be after after 12 years? All right. So once again, we see this key word first off, compounded. As soon as you see that word, guys, you know you have to use this equation. Okay, as soon as you see that word, you know you have to use your runny nose needs tissue. Okay, compounded gives it away that is the equation you have to use. Now we just have to figure out what each of those values are. So A, our P, R, our N, and our T. So initial deposited amount was 3,000, so that is my P. All right, my my rate is 5%, but as a decimal, this is actually going to be 0.05. All right, next it says it was compounded semi-annually. Try to resist going back up to the front page, but if you need to, go for it. Semi-annually means twice a year. So my N is going to be 2. And finally, it says, what will the balance be when Amanda is 12? Well, that's 12 years that have passed since she was born, so my T is 12. The only thing I don't have is my A, so that's exactly what I'm going to find here. So I'm going to write A equals P, which is 1,000, 1 plus R, which is 0.05, over N, which is 2, and then n again, which is another 2, times t, which is 12. Again, use that trick, guys. Rewrite this here, but now it's going to be 1 plus, and you're going to want to put a parentheses here. So a second set of parentheses just for that division. And then finally, figure out what 2 times 12 is. Hopefully you can figure out that that is 24. This is what I need you guys to type into your account. Type that into your calculator and see what you get. Let's go ahead. I'm going to do it with you guys to make sure we get the same value. So this is 3,000 times 1 plus another parentheses. So far on my calculator, I did 3,000 open parentheses, 1 plus another open parentheses, 0.05 divided by 2, close one parentheses, close the second parentheses, and now raise to the 24. So this gives me 5,426 and 18, because we're talking about money here, so I'm rounding to the nearest hundred. And don't forget to write your units. So my compounded interest after 12 years, together with the money that was originally deposited, adds up to a total of $5,426.18. Okay, so if you didn't get that, more than likely you are entering something wrong on your calculator. So make sure it looks exactly like this that you're entering into the calculator. Okay. All right. Part B says, what will the balance be for Amanda? When Amanda goes to college. She will go to college when she is 18 years old. So, what's the only thing that changes? Still the initial amount, still the same rate because it's in the same bank. Okay, still compounded semi-annually. That doesn't change. The only thing that changed was my time. So now, instead of 12, I'm going to use 18. So once again, let's do our equation. So this is P 3,000. 1 plus my rate is still 0.05. My N is still 2. But now my T is 18. So once again, let's type in what we should, or let's write what we should be typing into our calculator. Oops. I messed that up again. Sorry about that, guys. Okay. And then let's figure out what this is. 2 times 18 is a 36. Oops. 36. That is what you should be typing into your calculator. Oops. Okay, so go ahead and type that into your calculator, guys. Let's see what we get. So we have 3,000 open parentheses, 1 plus another open parentheses, 0.05 divided by 2, close one parentheses, close the second set of parentheses, and then this is raised to the 36, and I got a grand total of $7,297.61. Again, we're talking about money here, so round to the nearest hundred. This is what you should have gotten as your answer. All right, guys. I think we've done enough of these problems where you can try one on your own at least. So why don't you guys go ahead and try number 3, and then we will talk about it, make sure that you guys have that right, and then possibly we will go over number 4, and you guys will be able to take care of the rest. Okay. All right, let's go ahead and do number 3. So go ahead and pause the video, guys, and try out number 3 for me, please. All right, again, let's highlight a few cute things here. So as we're reading this, we can identify and derive what we need. So it says in 2002, Lori deposits $10,000, okay, into a TCF savings account that pays 2.5% interest to start saving for her wedding. At TCF, interest is compounded monthly. What will the balance be in the account in 2010? So right away, I saw this keyword here, compounded. So I know I have to use our equation. I just like to always rewrite it so I remember. Runny nose needs tissue. And once again, I always also write everything I am looking for over on the left. So let's go ahead and see what we can find. It says Lori deposits $10,000 into a TCF bank account. So that's the initial amount that was deposited, $10,000. Right? Then it says at 2.5 interest. Okay, at 2.5 interest or 2.5% interest, we have to turn that into a decimal, which is actually 0.025. Okay, if that still doesn't make sense how I'm getting that, guys, remember, if this is the percent, just move the decimal to the left twice, meaning that there's a 0 here. So this is 0.025. Another way to do it is take 2.5 divided by 100. You get the same thing. So that's just for those of you who are still confused as to how I'm getting these numbers. All right, now it says at TCF, interest is compounded monthly. So our N is what? Monthly is every month, and how many months are there in a year? There are 12 months. Now, it looks to me like we're missing the A and we're missing the T, but one of those we could definitely find right from the problem, and that's right here. If the money was originally deposited in 2002, but then you're asking what the balance is at 2010, how many years have passed by? 8 years have passed by, right? So we have everything we need. The only one we're looking for is A, but that's usually what we're looking for anyways. So we have A equals $10,000, 1 plus R, which is 0.025, over N, and then N, oh, sorry, not over N. Well, what is our N, guys? Our N is actually 12. So go ahead and put that there. And then N times T, which is 12 times 8. That's what your equation should look when you substitute. Now let's see what it would look like, or what you should be typing into your calculator. So this is 1 plus, in a new set of parentheses, put the 0.025 over 12. And then we said that 12 times 8 is actually, get my pencil here, 12 times 8 is actually 96, if I'm not mistaken. So that we can type into our calculator. So let's go ahead and do that. So 10,000, open parentheses, 1 plus another open parentheses, 0.025 divided by 12, close parenthesis, raised to the 96. And I got, and hopefully you got, 12,200, if my pen would write, $12,211.49. So this here is what you should have gotten as your final answer if you substituted everything in correctly. Okay. Now it says, what will the balance be today? Well, right now it's 2016. So that means from the year 2002, when it was originally deposited, to the year now, which is 2016. Okay, let's see what that would be. 2016 minus 2002. What's that? That's 14 years. So that's our T. So that's the only thing that's going to change here, guys. So let's go ahead and use the same equation. So 10,000, 1 plus 0.025 over n, which was 12. Now it's 12 times my new t, which is 14. Again, I like to write a whole new one so I know what I have to type into my calculator. 1 plus, and notice guys, all I'm doing here is making sure you put the correct parentheses in your calculator, because otherwise, trust me, your answer will not come out to what it should be. So now 12 times 14, that is actually, I believe it's 156. No, I was wrong. It was 168. So this is 168. All right, let's go ahead and type that into our calculator. 1,000, or I keep saying 1,000. Sorry about that, guys. 10,000. Open parentheses 1 plus another open parentheses 0.025 divided by 12. Close parenthesis, raised to the 168. I got a total of 14,185 and $51. Okay, so if you did get that as your answer, you are absolutely correct. All right, so after 14 years and depositing an original $10,000, you've actually increased the amount in your bank account, if you were at TCF, by $4,185. Okay. Unfortunately, interest rates aren't that great nowadays, so yeah, you probably aren't gonna find something like that, but you might. I just haven't found one. But anyways, it says for part C, which is the last part here, it says, what would Lori have? I'm sorry. Would Lori have more money in her bank account today if TCF compounded interest quarterly? Ooh, that's a good question. So instead of compounding monthly, like we did up top, what if they compounded quarterly? And quarterly is 4. Okay, so why don't we go ahead and do this? I'm going to rewrite my problem. Remember, this is still the same, and everything should stay the same. The only thing we're changing now is, our n value, okay? So now, and actually, why don't I write that here on the side? Our n value is now going to be 4. Our t is still going to be 14 because we're talking about what it would be today. Our r is still 0.025, and our p is still the original $10,000. Okay, so this is 10,000. 1 plus 0.045, whoops, 0.025 over, now this is going to be over 4, and then 4 times t, which is 14. All right, let's rewrite this again so we know what to type into the calculator. So it's 1 plus 0.02, oops, I forgot my other color. 0.025 over 4, and then 4 times 14 is what you should be calculating over here, and that one I believe is 56. So let's go ahead and figure that out, see if we actually would be getting more money if TCF compounded interest quarterly. So 10,000, open parentheses, 1 plus 0.025 divided by 4, close parentheses again, raised to the 56. I actually got $14,175.23. So let's compare the two. Monthly compounded, you would have gotten 14,185. Quarterly, you should have gotten 14,175. So it's a $10 difference, but I would say definitely going with the monthly is a better choice. So the final answer here would be yes, you would want to go monthly. Okay. All right. I think. Oh, let's scroll down here. There we go. Okay. I think what I want you guys to do is maybe one more of these, and then you should be able to finish the rest of them. So why don't you guys actually go ahead and do number 5 for me, please? And then we'll come back to talk about it and see how well you did on that. All right, guys, try that out. All right, so number 5 says if you deposited $6,500 into an account paying 8% annual interest that is compounded quarterly, how much money will be in the account after 7 years? So I saw my keyword I always look for is compounded. That means I have to use my equation, my runny nose needs tissue equation, okay, and not my exponential growth or exponential decay equation. All right, so now let's see what we have. A, P, R, N, T. Let's look at what all of these values would be. Well, my original principal or my original initial value is 6,500. My rate is 8%, turned into a decimal is 0.08. N is quarterly, meaning 4. And my T is 7. So the only one I'm looking for is A, like usual. Let's go ahead and substitute those values in here. Okay, so this is 4 times T, which is 4 times 7. Let's see what we would actually type into the calculator. Again, all I'm doing here is calculating what this is first and making sure I put this in its own set of parentheses. So this is 6,500, 1 plus 0.08 over 4 raised to the 4 times 7 is actually 28. Let's see what we get. 6,500 open parenthesis 1 plus another open parenthesis 0.08 close. I'm sorry, divided by 4, then close parenthesis, close the second set of parentheses, and then raised to the 28th. If you got what I got, then you should have 11,316 dollars with 66 cents. Okay, $11,316 and 66 cents. So go ahead and confirm your answers, guys. Make sure that is what you got. If you didn't get that, more than likely there was some sort of issue here. So make sure this is what you're typing into your calculator. Okay, guys. All right. I think I'm gonna actually go ahead and end the video there. Today's video actually was a little long, not too crazy, but at least we are having a little bit, hopefully have a little bit more of an understanding of compound interest type equations. So again, these are up here the key things that you have to look for. As soon as you hear the word compounded, guys, in any one of your problems, even on your like test, quiz, anything like that, as soon as you hear the word compounded, you know for a fact you have to use this equation, the runny nose needs tissue equation. Okay, and just remember what each of those things means. You will definitely be seeing things like monthly, semi-annually, weekly, and quarterly. Okay. All right, guys, I think I'm going to leave you there. Go ahead and try out the final 2 problems on your notes. If you are done with those and feel comfortable, go ahead and move on to your homework. All right, guys, that's it for Unit 6, so I will see you guys next time. Take it easy. Bye.